So for photo emission means photo emission here it means that when we fall incident the light of specific frequency on the metallic surface, then the photo emission of photoelectron which are emitted as the results of incident light, and then is there for their photo emission the energy of incident light h mu should be greater than or equals to w naught. W naught is called as work function of metal. It is called as work function of metal. So it is work function of different metal is different. It is specific. So we can say that work function is specific for every metal. Every metal has its own work function. So now what is the work function? So it means that when metal absorb the electron h mu, then the some minimum amount of this energy is used to work W to overcome the attractive forces of metal. So work function is the work which will be done to overcome the attractive forces of metal which bind the electron, and the remaining energy of the electron of remaining energy will be converted in the form of kinetic energy of emitted electron. So we can say that the maximum kinetic energy of emitting electron will be equals to h mu minus w naught. So here this is the energy of incident electron, and energy equals to work function w naught will be used to overcome the binding forces within the metal to free the electron, and then remaining energy will be used as the kinetic energy of emitting electron. So this equation is known as photoelectric effect equation, known as photoelectric Einstein photoelectric effect equation. This is as Einstein gives us the idea of photon, that is energy consists light consists of photon as which are the discrete packet of energy. So this is called as Einstein photoelectric effect or Einstein photoelectric equation. So how this theory explain the drawback of wave theory? Now we will discuss all these drawback and how Einstein explained these drawbacks. As the first drawback of wave theory was that that was the non-dependence of maximum energy on the on the intensity of incident radiation. So this was the first drawback, that why maximum kinetic energy does not depend on the intensity of incident radiation. Now the wave theory was failed to explain this fact. But how Einstein photoelectric effect theory explained this fact? According to the Einstein photoelectric effect, intensity can be defined as it it can be defined as it is the number of photon. Intensity is actually the number of photon in the incident beam, so which is passing normally through a unit area cross section, passing through a unit cross sectional area, passing through a unit cross sectional area of incident beam. So intensity, when we increase the intensity, it just increase the number of photons. Increasing the intensity, it will just increase the number of photons in the incident beam. So as a result, when we fall the light of large intensity on the metallic surface, it will just increase the photocurrent. It will just increase the photocurrent, not their kinetic energy, because the kinetic energy is not related to the intensity. Kinetic energy is related to the frequency. As frequency and the kinetic energy has their relation, so it's only kinetic energy of emitting electron will increase only when we increase the frequency, but incident, when we increase the intensity, it will just increase the number of photons in the incident beam, and as a result it will increase the photocurrent, emission of photoelectron, which result in the increase of photocurrent. So there is no relation, there is no dependence of maximum kinetic energy of incident radiation, as Einstein already has explained that if we have the metal surface and these are the electrons, so the incident photon gives all its energy to the electron, and as a result it will be emitted. So single photon gives off all its kinetic energy to the all of its energy to the electron. As a result, it will be emitted from the metal. So increasing the number of photon in the incident beam mean increasing the intensity just means to increase the number of emitted photoelectron. It does not depends on the kinetic energy of incident kinetic energy of emitted electron. And the second drawback of wave theory was that according to the wave theory there is the existence of threshold frequency. Existence of threshold frequency. As we have experimentally observed that there is the specific frequency which is needed to emit the electron from metallic surface. But wave theory cannot explain the threshold frequency, as we know that according to the wave theory, electron should be emitted at all frequency for a for sufficient intensity of incident light. But there was nothing was like this was observed when we performed the experiment. So according to the Einstein, there is a specific threshold frequency mu naught for a metallic surface. This is the minimum frequency. Minimum frequency for a metal, and it's specific for every metal has its own minimum frequency. So this is the minimum frequency of the photon, which just has the sufficient energy to liberate the electron from the surface with zero kinetic energy. So we can say that as we have the equation of maximum kinetic energy, mv square maximum is equals to h mu minus work function w naught, as the h mu as the minimum frequency. H mu naught is the minimum frequency which can liberate the electron from metallic surface with zero kinetic energy. So we can write it like H mu naught minus W naught work function. So mu naught will be equals to W naught over H. So minimum frequency can only be explained with the help of Einstein photoelectric effect, and that is minimum frequency is related to, again I will tell you that frequency is related to energy. And so when the photon of frequency h mu naught, which is equals to threshold frequency, strike on the metallic surface, it gives off all its energy to the electron within the metal. As a result, electron will be emitted. So this is the minimum amount of frequency which is needed by the electron just to be liberated from the metallic surface with the zero kinetic energy. We cannot explain it with the wave theory of a photoelectric effect. For the wave theory of photoelectric effect, the photo emission should occur at all frequency for a sufficient intensity, which was not which is not true when we observe the thing experimentally. And there was the third drawback of this theory was that lag of no lag of time. No lag of time in according to wave theory. There was no lag of time was cannot be explained according to the wave theory. According to the wave theory, when electrons as these are trapped within the metal, and so there are some binding forces which bind the electron within the metal. So according to the wave theory, when radiation of some intensity fall on the metallic surface, the first electron should collect enough energy and then it can be emitted from the metallic surface. So there should be a lag of time. But when things was experimentally observed, it was observed that there is the no lag of time between the irradiation of the surface and emission of photoelectrons. So this thing cannot be explained on the basis of wave theory. This can only be explained when we consider the Einstein photoelectric effect, that is incident light consists of photon. It consists of photon of energy h mu. So energy of photon is not distributed over an area as in the case of wave theory. So it is in the form of concentrated bundle of energy. It is these are the discrete packets of energy. So when the photon with a specific amount of energy h mu is incident on the electron, its all its energy is absorbed by this single electron. So this electron, when absorb the energy of incident photon, it will be emitted from the metallic surface without any lag of time, as we can explain it with the help of photoelectric effect. So This was an important to consider the Einstein photoelectric effect condition. So conclusively, we can say that this effect therefore gives us one of the most conclusive indication of particle properties of electromagnetic radiation. That is only when we consider that the photoelectromagnetic radiation consists of discrete packet of energy or photon, then we can explain the photoelectric effect. We cannot explain it on the basis of wave theory. So this was all about the photoelectric effect. Thanks for watching. For more videos, please subscribe our channel.